Hey guys, I'm here to do episode 5 in my Project SeaCAT series. This one is going to be on what I call the deduction test. So this test has one purpose, and it is to check for insanity. Now, I believe the definition for insanity is doing the same thing and expecting different results, right? So you do something, you do it again, and you expect a different result to what you did last time. So we're going to see if an AI should be smart enough to do that. You would imagine it would be, right? You don't want an insane AI. You just don't, for obvious reasons. So you're going to get this presenter view in the bottom because I'm using my mouse to skip slides, because I want to use it for pointing, hopefully to help get my point across. So, we start off with the same layout we had in the logic test, which I have come to the conclusion the logic test doesn't actually prove anything new. So that's being thrown out of my tests. The light bulb test is still good. That still proves feedback works. But the logic test didn't actually prove anything. We realized that in the video yesterday. So, we've got our original setup, and in this video I'm going to try and go through the steps as to what this test is and how it proves intelligent behavior. So how it proves it is not insane, right? This is this is replacing the dog treat test. It's basically a simplified version of the dog treat test. So we've got two buttons and we've got two lights, and what we're going to do is we're going to teach the SeaCAT AI, or whatever AI it is, that each button maps to a different light. That's fair enough. So pressing this one should turn this one on, say, and pressing this one should turn this one on, right? That's reasonable. That's what we're going to try and teach it, using our positive and negative feedback, which we tested worked in the light bulb test, which I'm going to rename to the logic test, right? So the logic test is the light bulb test. So we've proven logic by doing the light bulb test, and we've proven judgment. Now we want to prove sanity and reason, right? These are just buzzwords, I guess, but they are concepts that we want to be trying to prove. I like to look at it as if I was the SeaCAT AI and those were the only inputs I had and those were the only outputs I had, what would I do? You know, that would be, I guess, how you would judge AI. What would I do, and is it doing it? So, let's begin. I've tried to clean up my presentation method a bit, you know, always improving, etc. So we'll see how it goes, see if I don't get confused this time. So we'll just jump right into it. At the start, we haven't pressed any buttons. So what's the AI going to do? We learnt this last time. It's not going to do anything, right? It's got nothing to do. So we're going to reward it because we don't want it doing anything when none of the buttons are pressed, right? That's fair enough. However, now we want it to do this. So we want it to respond to this button, and we want it to turn on this light. So we've pressed that button. What's it going to do? It has a few options based on the logic that we gave it in the last test. So I'm going to skip that stuff. For that reasoning, you can go into the previous video. Otherwise, these will get too long. So it picks an action that it hasn't done before, is basically the conclusion we reach. And no, it doesn't. The conclusion we've reached is it does nothing. I'm skipping ahead. So it does nothing because doing nothing has rewarded it in the past, right? Doing nothing got it something. But now it's doing nothing when there is an input. We need to punish that, right? Or give it negative feedback. Punish is a harsh word. It's not even give it negative feedback, it's just give it the other type of feedback, you know? And it's associating these with two types of feedback. One that it likes and one that it dislikes. So I guess it is positive and negative feedback. So we keep the button held down. It's going to look at these. It's going to say, that was good, but that was bad. The button is down. That means I can't do this. So I'm going to turn on a light. But it turns on the wrong light, right? We could consider that the right light if we wanted. It wouldn't make a difference to us in our test. But hypothetically speaking, let's assume we wanted to turn on this light, right? So we want to change the AI's behavior using feedback, basically. That's what training is, right? So we want to train this thing. Don't do this. So we give it negative feedback. So what does it do? We keep the button held down. Now I wonder what people think it's going to do. Personally, what I think it would do is this. Now it could go either way. It could turn this light off and turn that one on. But it didn't. Because why would it turn that one back off? I can't think of a reason that it would. Except maybe it's been rewarded for having it off twice and it's been punished for having it on once. So maybe it would turn it off. Maybe it would turn it off. That's getting into complexities though. You could imagine that it didn't turn it off and that would be fine as well from my perspective. That would be totally fine. I would be okay with that. I would still call it an AI. Because I think that's fair. I think that's an easy mistake for it to make. There would obviously be sliding scales on this stuff. So this is my worst case scenario, right? This is my worst case scenario for what I would consider an AI. So you keep the button held down and it turns off the other light. It's got it figured out now, right? It's got this down to a T. So we reward it. Brilliant. Now we let go. What does it do? Well, it turns the light off because it knows when we've let go, it should turn its light off. So that's what it does, right? It turns the light off. But we don't reward it because we've already rewarded it and we don't want to start giving it too many rewards for turning the lights off, you know. We could. I don't think it would make too much harm, but it might do. Later on, it might cause a bit of unpredictability. I'm being super rigid in these tests, or I'm trying to. Obviously, I'm coming to new conclusions as I go, but I'm still trying for worst case scenario here. So, number 7, we press the second button. What's it going to do? Well, it's never seen this button before. However, in the past, it's had inputs, right? So it may decide to turn on this light, because when there was input, this light was on, right? Alternately, it might decide to do nothing, right? Again, this is where the training comes in. I would say the reason I think it would turn the light on comes back to the sanity business. So he knows that doing nothing got him a reward, right? So potentially he could think, I guess this depends how much reasoning the AI had truly, but you could train it up, and that's the whole point. For this case, he has decided, using whatever criteria he has, that doing the same thing, putting the same outputs as here isn't the right move, because he had no outputs when there was no inputs and he got rewarded, but now there is an input, and when there was an input he got rewarded for turning this light on, right? So when he gets a different input, why would he not turn that light on and get a reward? That's my thought process going through this. There are obviously different paths it could take. This is going for worst case scenario. Again, I don't know why I keep repeating that, but I feel like it's a significant point to make, that even at this point the behavior could have diverged, but you would just keep it back on track by using feedback. I think the things that would change that would be like sliding scales and random chance, which you could program in. So like risk aversion, you know, how likely is it to take a chance instead of just doing nothing? You could definitely give it some sort of impulse where it didn't like doing nothing, or it would prefer to do nothing, you know? I think that's something that you would tailor for each AI in the end, using some program, sliding scales, all that shit. So we punish it because it pressed the wrong button, right? We keep the button held down, and it turns on the correct light. It turns on the light and we reward it. Now, why did it turn on the correct light? Well, it knows that when an input is down and it's got both lights on, it gets punished. So it can assume when an input is down, both lights on, it's going to get punished. So it turns this one off. You could argue that it could have just turned the light back off? Potentially, again, that's a branching thing. It could have decided to go back to the norm where it had a chance of getting a reward. However, not necessarily. But again, you could tailor it, you know. If it was doing the wrong move, you would just keep feedbacking it until it was behaving correctly. That's what you would do. So basically, no matter what its personality, with an AI, you can always bring it back on track with feedback. Always, I think. That's what makes it an artificial intelligence. It doesn't have like hormones and stuff messing about with its thought processes, so you can use pure logic on it and you can use pure feedback to get it into place. You can manipulate it entirely, I would say. Probably. That would be my definition of an AI. If it couldn't be fully manipulated, it would be more than an AI. Because there would be something going on. I think that's the conclusion I'm reaching here. Because even with all these diverging paths, you can bring it right back on track with a bit of positive or negative feedback. You know, it'll always bring it right back into the zone. That's what I'm seeing so far anyway. That might be a false conclusion. If anyone else has any other conclusions, they should let me know, because I'm really interested. But that's the conclusion I'm reaching. So we finally got it to do what we want. It is now at the stage where you could press either button and it will turn on the correct light. So now it is 2 light switches. Again, pretty cool, but not that impressive. We haven't done anything impressive yet. This is still just the logic test level of proving stuff. So let's see if we can go above that. We might not be able to. I might reassess as I go through this presentation, but we'll find out. Now, we're going to add an extra button and an extra light. So how many iterations will it take us from here to get him to learn that this is mapped to this? And this is where sanity comes into it, right? This is the difference between logic and sanity, in my opinion. So, we hold down the new button. What's he going to do? If you had to guess what he was going to do, what would you guess? I'm going to tell you the answer anyway. The answer is, in my opinion, he does nothing. The reason I say that is because he has looked here at this grid and he has seen that if he does nothing, either nothing happens or he gets a reward, right? There's never been negative consequences for him doing nothing while these two buttons weren't down. It's never happened. And this ties to the dog treat test with Neil deGrasse Tyson that I was talking about in an earlier video, in that with some positive and negative feedback you have taught the dog, which is the AI basically, to get the correct toy based on what you say to it, right? That's what we're proving here. You've got the toys, which are the lights, and you've got the command you're giving the dog, which is the buttons. So up to iteration 8, we have taught it to get two different animals, or two different toys, by using two different commands. Now the important thing here is what you see in that Neil deGrasse Tyson video. I'll try and find it and put it in the description for this video if I remember. It's a hard ask, but it might be there. If not, just Google like, shit, I don't know what you Google. Neil deGrasse Tyson dog experiment, maybe. You're obviously clever guys, you'll figure it out. The first time, when he reaches this point and then he says, we've added a new dog to the pile, or a new toy to the pile, right? They've added a new toy to the pile behind the sofa. They've put this pile behind the sofa and they've added an extra toy to it. And Neil deGrasse Tyson and this dog owner trainer guy are on the other side of the sofa. And so they reach this point and they've given the dog the commands and it's going round and getting the toy and coming back, and they're proving it works, and they're like, yeah, great. And then he's like, now here's the interesting thing, and they put the extra toy in there without the dog seeing, I think, and they give it a new command, right? They say, like, instead of saying get the ball, they say, like, get the doll, right? And so it has to go round the back, look at all of the toys, and then what it does is very interesting. It doesn't pick up the new toy. It actually comes back empty-handed, right? And Neil deGrasse Tyson just repeats himself, right? So he doesn't reward or punish the dog. He just repeats himself. So here, we're not going to do anything, right? We're not going to do anything, because that's what Neil deGrasse Tyson did in that video. And this is supposed to replicate that. Now, we press the button again, right? It's very, well, I feel it's very important, this section here, where we do nothing. It picks it up. Why? This is a question you'll be asking now, because I don't know if you see the justification for it. However, I'll try and go through the motions. See if I can remember them. So, let's look at his past experiences up to this point. He knows that keeping this square may get him a punishment. Right? A reward, right? This square gets him a reward sometimes. Sometimes it doesn't get him a reward, but it never punishes him. He's never been punished by this square. Not once. So he's not going to mess with that, right? Unless he has to. Unless he has to. He's not going to mess with that. That's like the status quo for him, you know? It's sometimes good, sometimes you just don't worry about it, so it's not an issue. It's only an issue if one of these two buttons is pressed, right? That's like a self-contained experience in his eyes, currently. Now here, he's had that self-contained experience. So if you ignore that, he's just got this again. We're back to the light switch test, right? He tried doing nothing, didn't work out for him, he got nothing out of it. We could have punished him, but we didn't. If we'd punished him, I think we would have made it more certain that he was going to do this. We would have guaranteed it, I think. If we'd punished him for coming back with nothing, I think he would certainly have done this, but I'm not cruel. Neil deGrasse Tyson isn't cruel, I guess, because they just repeated the question. So it seems like when you repeat the question, you will have a chance that he will do the right thing. But he's very unlikely to mess with this, right? Especially if he's messed with this in the past and you've punished him for it. Which I haven't done here, but you could start out with that, right? Like you could do nothing until he lit a bulb and then punish him. And then he would be far less likely to mess with this empty square. So using that reasoning, he has cut this down and he turns the correct light on. And then if you brought in another bulb, he would reach that same reasoning, I imagine. And so on and so on. Especially if we rewarded him for that. Because he would be being rewarded for keeping this square. Always. And if we let go of that and he didn't cut that out, that would be interesting. I would need to look into that in more detail. However, that's the final iteration that proves the dog treat test. That's all there is to it, really. I mean, I think it proves that the dog is sane, you know? It's not, or the AI, not the dog. The AI is sane. Because it's not doing things that could be positive to it. And it's not repeating itself when it gets a negative action. Now you could argue, again, this is just a very complex if statement, but if anyone's got any reason as to why this test is not proving intelligence, I would be very interested, because it is simulating the behavior of a dog in a video. You could argue it's not intelligence, it's just simulating a small aspect of the dog, definitely. But it's a quality of the dog that we find very impressive. Well, Neil deGrasse Tyson finds very impressive, I guess. I'm not sure how impressive everyone else finds it. I didn't find it that impressive. But I did find it to be a measure of intelligence. Which means that if my SeaCAT can do this, that is a measure of its intelligence, right? Either that or it isn't for the dog. One of the two. So that is why I think this is a valid AI test. I do believe I should have changed this to say 10, but I clearly didn't. That's fine. And yeah, that's that. I did come up with another test earlier, which I might do a video on tomorrow. What was it called? It was like the compassion test or something, and it's all about watering a plant. But I'll cover that one tomorrow. Today I am done, I think. Yeah, I think that's me. Catch you later, guys.